Hi guys, I hope you're well. If you hear a weird noise in the background, by the way, it's not me bouncing on my bed because I'm really happy. It's my daughter on the trampoline. Right, so nearly at the end of chapter 12, we've got a little bit on regression lines, which sounds like something new, but it really isn't. It's the posh A-level word for a line of best fit. And we've already looked at interpolation and extrapolation before, but we'll be just going into a bit more detail. So let's have a little look at scattergraphs. I hope you don't mind that I didn't do a video for last lesson, but I thought insulting your intelligence a little bit if I was to do a video showing you how to plot a scattergraph. So we've got some posh new words here as well that you may not have seen before. The x-axis is the independent variable, and you'll also see the word explanatory. The y-axis is a dependent. So this depends upon this, and we call it the response variable. So we've got specific names for these now. Now back at GCSE, you would just draw a line of best fit through your centre of the data here. And some of you would automatically try and connect it to here because for some reason everything's got to come from the origin. At A-level you need to be a bit more precise. So we will be working out the mean point, and the line of best fit has to go through the mean point. So I've got an example here. It's showing the reaction time in people of different ages. Obviously from the data here you can't quite tell what the pattern is, but once we've plotted it here we can clearly see we've got some kind of positive correlation, quite a strong positive correlation, suggesting that as people get older your reaction time slows down, as you'd expect. Now if you've got your calculator to hand, you could actually plot this as your x and this as your y, and you will, if you've got a graphical calculator, you can plot the scatter graph and it will plot a line of regression for you. Now you're used to seeing y equals mx plus c to represent the equation of a straight line. We use A and B at at A-level, not at GCSE. So this is what we use at A-level. A here is going to be your intercept, and B is your gradient. Be really careful when you use a calculator because for some reason they have A plus BX, but they also have AX plus B, and obviously you'll get your A and B the wrong way round if you use the wrong one. So cheese. Hello guys. I wanted to say happy Monday, but I'm not actually sure what day it is when you're watching this. And to be honest, I don't even know what day it is now. If you hear a really weird noise in the background, it's my daughter on the trampoline. It is not me bouncing up and down on my bed, by the way. So let's have a look at regression lines. Very straightforward, to be honest. It's the posh A-level word for the equation of... Hello all, hope you're all well and keeping safe. I thought we'd look at regression lines today, but firstly, just to warn you, my daughter's in the background on the trampoline, so if you hear a really weird noise, that is what it is. So, regression lines. Posh A-level word for line of best fit. So you have done this before. There's just going to be a little bit more notation. There's going to be some calculator usage as well in this. We've also done interpolation and extrapolation before, so none of this should be hugely new to you. There's a couple of words here that you might not have seen before. So we've got our scatter graph here. The x-axis is referred to as the independent or the explanatory variable. And on the y-axis, we use the word dependent or response. So this axis is usually dependent upon the x-axis. So the arm span here depends upon the height. I've got a lovely little table here showing reaction times in people. And from here, you can't quite tell what is going to happen with the data. But if you plot it, we can clearly see we've got a lovely positive correlation here, quite a strong one. So that means as you get older, as you'd expect, your reaction times slow down. If you've got your graphical calculator with you, you can plot this as your x and y, and it would plot the scatter graph for you. Now you will be used to seeing y equals mx plus c, where m is the gradient and c is the intercept. In statistics, and just to confuse you, we use a and b, and a is your intercept and b is your gradient. And you've got to be really careful because on the calculators you have both options. They give you y equals a plus bx and y equals ax plus b. I'm not quite sure why, but if you select the wrong one, you will get your a and b the wrong way round. So please be really careful with that. So before I go into this actually, let me just quickly recap what you would do with a line of best fit, because back at GCSE you would probably just draw a line all the way through this. Maybe even starting at the origin, because quite a few of you seem to think that's what you had to do. I've also seen this as a line of best fit. So generally, your line should go through the data, roughly so there's half the points on either side. I think we can all agree that that is not the most accurate way of drawing a line. So what we do at A level is we plot the mean point, and that allows us to have a slightly more accurate line. So I've got some screen captures of my graphical calculator here. I'm sorry the quality is poor. I've done the best that I can. And you've got my thumb in pretty much all of them. So on this first one, what I did was I went to the statistics mode and I just entered my data. So I entered my X data and I entered my Y data. So from this table here, I entered X against Y. I then went to calculate, and you get something like this come up. Hi guys, I hope you're well. I'm so missing our lessons, and I know Hypatia is missing you all too. She's in isolation with me, not really enjoying herself, but we're making the best of it together. So anyway, firstly, if you hear a bit of an odd noise in the background, it's my daughter on the trampoline. So we're going to look at regression lines. Sounds a bit like a new topic. It's not really. It's a posh A-level word for a line of best fit. Only obviously we're going to make it a little bit more accurate than we would have done at GCSE. We've also looked at interpolation and extrapolation already, so this shouldn't be a particularly difficult lesson. I apologise I didn't do a video for last lesson, but I did think you'd be a bit patronised if I showed you how to draw a scatter graph. So we've got some new words here. We've got some posh words for the x-axis over here. I'm not quite sure how I selected that then. Interesting. Let me point to it instead. Here we go. Independent or explanatory variable, and the y-axis is the one that's dependent upon the x. So we call it dependent or sometimes the response. So the arm span is dependent upon the height. And we've got a lovely little positive distribution here. If you were to draw a line of best fit, I'm sure you'd agree that you'd probably just draw a line through it, maybe like that, maybe like that. it wouldn't be hugely accurate. So we're going to be looking at working out the mean point as a kind of pivot, if you like, for your line of best fit, to give you a little bit of an idea where it should go. Okay, so we've got here the reaction times of some people of different ages. Can't quite tell from here what the distribution would look like, but once we've plotted it, we can see we've got a fairly strong positive correlation here, meaning that the older you get, as you'd expect, your reaction times generally slow down. You will be used to seeing y equals mx plus c. However, that's not what we use for regression lines. We use a and b instead. A is your intercept and b is your gradient. And on your calculators, you will have a plus bx, but also ax plus b. Make sure you choose the right one, otherwise your a and b will be the wrong way round. So I've plotted this on my calculator. I apologise if you haven't got a graphical one. I'm going to attach a PDF to show my homework that shows you how to do this on the class whiz. So I've started off here by plotting my data. So in the stats mode, I've entered my X data and my Y data. If you then press calculate, you get an option of 1 var, 2 var or reg. Okay, I apologise, I think those two might be the wrong way round. So you press 2 variables because that's what we're dealing with. We've got X and Y variables. If you had a list of X data and this was frequencies, it would be 1 variable. X and Y, we've got 2 variables. You press 2 variables, and what you get is this kind of data here. Now, what I should point out, I'm just going through my calculator as well, and I get a different kind of option come up, which you might as well. So I have something called set over here. Now, when you press set, you get this option come up, okay? So if you're dealing with 2 variables, you want to be looking at the 2 variables here, and you want to select list 1 and list 2. You can ignore what's happening up here with 1 var, but for 2 var, 2 variables, you wanted to say list 1 and list 2 and not frequency. Okay, so you get that by selecting set. Okay, so we've clicked 2 variables, and this is what you get. So you get some information here. We've got loads of stuff. So it tells you what the sum of x is and the sum of x squared. It also tells you the standard deviation and the sample standard deviation. All of this really useful if you're trying to check your answers in the exam. So we've got x bar and y bar. So we've worked out the mean point. I can then plot that on my graph and draw a much more accurate regression line. So that's how you work out your mean point. Now, if you go back to your table, next to 1 var and 2 var, you have something called reg. That stands for regression. I have absolutely no idea why you press X or what it even means. Okay, I don't know. But you press that button and you get 2 options here. And this is what I was talking about earlier. So we will be using y equals a plus bx. It doesn't really matter if by any chance you press that one, as long as you know that a will be the gradient and b will be the intercept on that one. But try and be consistent. So that's one we want, a plus bx. When you've pressed it, you get your value for a and your value for b. So a here is 0.58, so your intercept is 0.58 and your gradient is 0.09. Okay, the rest of them don't worry about yet. There will be a point where we will be using R. R stands for the correlation. It's actually Pearson's product moment correlation coefficient, and it tells you how strong the relationship is between them. If it's nearly 1, that's almost a perfect positive correlation. Close to -1, and it's a perfect negative correlation. The closer it is to 0, the more kind of no correlation you've got. That was very badly worded. So 0 means no correlation, -1, perfect negative, and a positive one would be perfect positive. Okay, so you've got a kind of sliding scale there. So that is almost perfect positive. But again, don't worry about that yet. That will come up, I think it might be next year actually, in the statistics. So we've got our intercept and our gradient. So I can then fill these in to my equation here. Okay, so what I've done first, I've plotted the mean point. But again, you still get this kind of, oh, where does my line go through? So once we've filled in our A and our B, we'll be able to easily work out the intercept. Once you've got the intercept, you can make it go through the intercept and your mean point, and you've got a very accurate regression line. So this is actually the equation of the line here, 0.58 being your intercept, 0.09 being your gradient. So back here, just got to try and remember that now. So A is, I'm just typing it into my calculator, sorry if you wonder what I'm doing. So A is 0.58 plus 0.09x. So your intercept would be somewhere around here. I apologise now for this really bad line, but you'd have a line, something a bit like that, going through your intercept and going through your mean point here. And that is then a fairly accurate model for this data. So we can then talk about some questions here as well. So this is my regression line. What do A and B represent here? So this is a very common question in the exam. They want to know, can you put these into context? Well, A here would be, and it's not just enough to say the intercept. We know 0.58 is the intercept, but what it means is that would be the reaction time for someone of no age. So, sorry, I'm going the wrong way. So I would put intercept is 0.58, so that's your A. This is reaction time for age 0. Okay, I'm now going to erase that so I can fit on the next bit. So you want to put it back into context. Okay, I know the context is a bit silly here because you're not going to give some kind of a test to a newborn baby and test their reactions. Well, I'm guessing not. I'm sure there are people out there who do that. But link it back to the question. Don't just say 0.58 is the intercept. And B equals 0.09. That's the gradient. So that means every 1 year, every 1 year increase in age gives a 0.09 second increase in reaction time. Now I've just realised it's not really an increase, is it? It's a decrease because you're getting slower. So I'm going to change that word to decrease. But maybe I should have thought about the wording of that, because I'm talking about times. I'm a little bit, I think I might have said every 1 year increase in age means you slow down by 0.09 seconds. It's a little bit better than trying to use the word decrease when I'm really, it's a little bit dodgy, isn't it? Have a think about how we could have written that better, but possibly saying 0.9 seconds slower would have been a little bit better way of me trying to explain that. So I do apologise for my lack of English there. I've not got many people to speak to, I'm afraid. You try talking to a 6-year-old all day. Okay, what would the reaction time be for a person aged 100? Okay, so I've got this really accurate regression line now. So I'm going to put in 100 into my regression line. And that will give me 9.58. So I'm expecting a person aged 100 to have a reaction time of 9.58. Now what we've done here is something called extrapolation. Our data, if we go back to the table, only went up to the oldest person here, 73. And although we can probably hazard a good guess that as you get older and older, your reaction times decrease and the time taken to do a task would take longer, we don't actually know. For all we know, this data could suddenly start going down after this. Maybe as we get older and older and older, we become superhuman. We don't know. Okay? So outside the range of our data, it's actually quite unreliable. So you might be asked to comment on this as well. And you should be using the words interpolation and extrapolation. So if you interpolate, you're looking at a value within the range of your data. And this is fine to do. It's actually quite accurate. But if you extrapolate, you're looking outside the range of your data, and that's not very accurate. That tends to be quite unreliable, and you would want to make a comment related to that in your answer. So you'd want to say, right, it's outside the range of my data, I've extrapolated, it's quite unreliable. I hope that's all made sense. If you try the questions from your chapter checklist, I've tried to only choose ones that don't rely upon you sketching a scatter graph. So have a look, try and get those done. And then we'll also have one lesson on the exam style questions as well before we link to the next chapter, which is looking at Venn diagrams, tree diagrams, that kind of thing. Right, best of luck. Please comment on any of this. If I've not explained it well, if you need further help with the calculator, that kind of thing, please let me know and I will answer any question that you've got. Right, good luck. Speak to you soon. Bye.